Hi, in this video, we'll be continuing the H2 Mathematics 2019 Paper 1. So, we left off at question 9, and for question 10, it gives you a parametric equation, and we're supposed to sketch it. So, we just use our GCE and we are able to sketch the graph, which will look like something like this. And the line of symmetry is something that we deduce from the graph, but you can of course find it from above. But instead, you just look at it and you see that it's symmetrical. Like this top half is symmetrical to the bottom half, so it's symmetrical along the y equals to 0 line. Then we're supposed to find the values of theta at the points where C meets the x-axis. So the x-axis means y equals to 0, so we just let this portion be 0. Because A is non-zero, the 2 sine theta minus sine 2 theta is 0. And 2 sine theta can be split into 2 sine theta cosine theta. Then we can take out the 2 sine theta because they are the same, then factorize them out. So it's 1 minus cosine 2 theta. So this part equals to 0 means sine theta equals to 0 or cosine theta equals to 1. And sine theta equals to 0 is at 0, half, and 2 pi. And cosine theta equals to 1 is at 0 and 2 pi. Now you just sub into here and see that 0 pi and 2 pi works. So these are the solutions to where C meets the x-axis. For part 3, now we're supposed to show that the area enclosed by the x-axis, the part of the curve above the x-axis, is given by this integral. So it means we only need to calculate this portion. And for this portion, well, when we know that it's the integral from minus 3a to a of y dx, then it's just from pi to 0, then y is the a sine theta minus 2 sine theta. Then for the dx part, you just need to find dx d theta, and again, it's the same type of thinking where dx equals to a bracket minus 2 sine theta plus 2 sine 2 theta d theta. So you just sub the dx as that and get this. Then with a lot of manipulation, you take out the a squared. The minus here will flip this sign because you want to integrate from smaller number to bigger number always. Then you just expand out these two factors and simplify it, and you'll get the required integral that you want, where theta 1 is 0 and theta 2 is pi. And hence, find in terms of A, the total area by C. So this is just top half of the area. So the total area is 2 times this top half. So you integrate that. And for each of these square terms, you must change it using the double angle formula. And you also apply the double angle formula to sine theta. And so you might be wondering, how are you going to integrate this? Well, you recognize that the derivative of sine theta is actually cosine theta, so this can be treated like the chain rule already. So it's just sine cube theta over 3, because if you think about it, when you differentiate this is 3 sine squared theta over 3 times cosine theta. These 3 cancel out and it changes this. So with that, you integrate it, and then you're able to sub in the values at 0 and pi. So the pi part, you see which terms cancel out. So all these signs will cancel out. So you left with 3 theta, so 3 pi. Then the 0 for 3 pi is just going to be 0, so it's just 3 pi. So it's actually 6 pi a squared in the end. Next, we have question 11, where it's a differential equation question. And for differential equation, like I always say, the most important is understanding how the question works. And so if we read the question, it says that the water is heated and placed at room temperature and when the room is kept at a constant temperature of 16. And the temperature decreases, so you need at a rate that is proportional to the difference between the water and the temperature of the room. So enter theta over dt now. So this is the rate of change of the temperature. It's decreasing, so it's minus k bracket theta minus 16. Theta is, of course, started from a higher temperature, since it's heated at the start. And then the reason why we have this minus is to say, because we want k to be a positive number, so we make it clear that this is the decreasing with the minus here. Then you want to integrate this part using variable separable, so you divide this portion, which is non-constant, over. Then you integrate 1 over theta minus 16. Then the other side integrate minus k. So this part is just ln theta minus 16. This part is just minus kt plus c, where c is constant. Then you want to remove the ln and modular, so theta minus 16 is just ae, because you bring up the e, so it's this e power c is a. Then you remove the modulus, it's still just some constant that is either positive or negative value. So it's ae minus to the power of minus kt. Then, so with this, now you want to solve for a and k. So first one, you solve for a, because you know when t is 0, this part is gone, doesn't matter what's the k. Theta is 80, since they say you start with a value of 80. Then a will then be 64. So when t is 30, theta is 32, then the difference in temperature is 16. Now you know a is 64, so it's e minus 30k. You can find k to be 1 over 15 ln 2. So theta is 16 plus 64 e to the power minus 1 over 15 ln 2 t. And with that, now you want to find the temperature of the water at 45 minutes. So you just sub t as 45 over here, and you'll be able to see that theta equals to 24. So I hope this is clear, and we can move on with the question. In the third part now, you're given another model, but in this case, it's about the thickness of the ice. So you want to model the differential, so the rate of change is inversely proportional. So you just put a k over t, where k is a constant, and you know that the thickness increasing, so k is positive. So in this case now, you just do the same thing. You bring the t's to one side, and the non-capital T's to the other. You integrate the capital T, and you integrate k. This becomes t squared over 2. This is kt plus c1. Again, you want to find the two constants. So c1 is 0, and we sub in t equals to 60. T is 1. Capital T is 1. So that means k is 1 over 120. So in that case, when t is 3, that means the thickness you want to know is 3. Then you just sub in. So 3 squared is 9 over 2. Then this is 1 over 20 small t. So t is 540. So up to now, if you have any questions, just leave it in the comment sections down below. I'll answer them. And that will be it for this question. For the last question in the paper, it is a vectors question. So in this question, it's really like a mathematical modeling using vectors question. So with all mathematical modeling questions, the most important step is that you understand how to do it. Understand the question, I mean. So in which case, so you read the question carefully. A ray of light is sent, so you just imagine it. You got sent from in a direction of -2, -3, -6. From 2 to 4, which is P. So you go here, hit the thing, refracted into the inside the prism, and refract out again. So the prism is placed such that the ray of light passes through the prism, entering point Q, and emerge from the point R and then hit the center at -5, -6, -7. So the acute angle is normal, is that, and beta is the other one. So given that the top of the prism is the plane x plus y plus z equals to half, so this is the plane x plus y plus z is half, and the bottom is x plus 1 plus z is -9. So we know that PQ direction is the same as RS direction, so both is the direction of -2, -3, -6. So now we're supposed to find the equation of Q and R. So the first thing is that we need to do step by step. To find Q first, we need the line PQ to intersect with the plane. So we need to find the equation on line PQ, which is 2, 2, 4 plus lambda minus 2 minus 3 minus 6. This is the direction vector as given. And 2, 2, 4 is the point P. So with that, then we find the equation on the top plane, which is r dot 1, 1, 1 equals to 1. So we know OQ is of this form for some lambda. Then we just dot it with the top plane since it also satisfies the equation. And we get that lambda is 7/11. With that, we can find what is Q, which is just sub the 7/11 up here again. So you get 8/11, 1/11, and 2/11. And the same thing for the coordinate of R. So you find the equation of line SR. So you got -5, -6, -7. And then you got mu, which is -2, -3, -6. And the bottom plane is 1, 1, 1 dot R equals to -9. Again, R satisfies this, so it can be equal to this vector for some lambda, for some mu. And we just sum it into the bottom plane equation since it also satisfies it. And we can solve for mu, which is -9/11, which allows us to get that R is -37/11, -39/11, and -23/11. As for the next part, now we are supposed to find the cosine theta, and theta we know is acute, so we just need to put the modulus using the formula. So the formula is dot the direction vector times 1, 1, 1 over the length of the direction vector and the normal. In which case you just simplify and you get 11 square root 3/21. Same thing for QR. No, so for cosine beta, now we just need to find QR and find the angle it makes with the normal. So just find QR because we know what's Q and we know what's R. Then we just dot it using the same formula for cosine beta, and we should get 11 over square root 510/255. So if you know the formula, you can use this. But another way to think about it is you have a vector here and you have a vector here. When you dot A dot B, it's just the length of AB cosine theta. So this theta is this. So that means A dot B over the two magnitudes AB equals to cosine theta. So if you look back here, what is cosine theta? Cosine theta is actually this vector dot the normal vector. That's why we do it direction dot the normal over the two magnitudes. So that's really how the formula comes about. And lastly, we're supposed to measure the thickness of the prism in the direction of the normal at Q. So what does that mean? It means that the thickness of the prism in the direction at Q, so from Q you just find this thickness, and you just see that it's actually this length cosine beta. And we already found cosine beta, so we don't need to do extra steps. We just take the length times cosine beta, which is 10 square root 3/3, and we're done. Next, Snell's law states that sine theta equals to k sine beta. So what's k? Well, we already found sine theta. We already know what's cosine theta. We know what's cosine beta. So theta and beta is just the inverse cosine of it. And then you just sine it. And then you just plug into your calculator and press the correct values, and you'll get 1.86 3SF. Because they never say it need to be any exact value. So you just use your calculator, quickly do it for 1 mark. And then what can you say about k when beta is larger than theta? Well, if beta is larger than theta, because we know sine looks like this, and then they're all acute, so it's over here, like this portion of the graph. So you just like beta is greater than theta, then sine will be the sine beta will be greater than sine theta. So k has to be less than 1 because sine theta is less than sine beta. Because you just divide here, like, so 1 less than sine theta over sine beta, which will k. So that should be fairly understandable. If you have any question, leave it in the comments. That's all for this video. In the next video, I'll go through the paper 2, so you can catch me in the next series. Bye!